Hello everyone. So today we are solving another question of JEE ADV 2015. This is on the topic of work, power and energy. So let's first read our question. It says they are given some two uniform disk rolls without slipping on the two different surfaces AB and CD. You can see in the figure this part is AB and this is the CD here. Starting at A and C with linear speeds V1 and V2 and always remain in the contact with the surface. If they reach B and D with the same linear speed V1 and V2, then what is, I think they have to find the V2 here, okay? So they are asking about V2 is equal to what? So one thing that we can do here is we can apply the, energy conservation here. Since they are not losing contact and rolling without slipping, it means there is no loss due to the friction here. And we can write all the kinetic energy and potential energy. So see what will happen here. If it is rolling without friction here from here to here, so there will be no loss due to the friction, but the only loss in the gravitational potential energy will be converted into the kinetic energy. Okay. So, and they are saying that they reach the point B and D respectively with the same final speed. Okay. So it means finally they have same kinetic energy or the same energy, I can say, because there, if we consider this point as potential equal to zero. Okay. If this point is equal to zero potential. Okay. Now let's start writing the equation. What is its initial energy of the our ball which has velocity v1? Okay. So it will be half m into v1 square. And what is its initial potential energy? It is equal to mg into what is the height? It is 30 meter. Okay. For the same which has v2 velocity, it has energy equal to half m into v2 square plus mg into height is equal to 27. Okay. Now what I have to technically do, I have to equate both of them. Okay. Also, I have to mention one thing that they, like, I should not write like this. They have kinetic energy plus some potential energy, and it also have some kinetic energy and some potential energy. The kinetic energy will not only be equal to half mv square because they are not some particle. It is also performing rolling motion. So what is the formula of kinetic energy of a rotating, substance here? So it should be equal to half mv square plus half I omega square also. Okay. So you have to keep this in mind as it is performing rolling motion also. It is not just simply slipping down due to the presence of gravity here. So how we can write kinetic energy for our first part? So it should be equal to half mv square. And we know that for pure rolling v is equal to r omega. Okay. So what is the moment of inertia for a disk kind? I think it's disk, yeah, disk. So it is nothing but mr square by 2. So half into mr square by 2 into what is omega square? It is nothing but v square by r square. So half plus 1 by 4. So basically it is equal to 3 by 4 times the mv square. We can similarly do for the second particle also. So let me write the final energy equation. So 3 by 4 into m into v1 square plus mg into 30. Now this should be equal to 3 by 4 into m v2 square plus mg into 27. Okay. Now we have to equate this basically. v1 is equal to 3 given also. So 3 by 4 into m into 3 square is 9 plus 30 mg. And let's first cancel mm also because they are identical. There is no matter of writing mm all the places. So this is 30 into 10 is basically it is equal to 300 is equal to 3 by 4 v square plus 270. And like doing all the calculations here. So 3 by 4, 9 minus v square is equal to, sorry, I should like in the another manner, 3 by 4, v square minus 9 should be equal to 30. Okay. And 4 times 30 is equal to 120 by the 40. So v square is equal to 49 here. It means v is equal to 7 meter per second. So initially our second ball has a velocity of 7 meter per second. And this is our final answer here. Thank you everyone.